Track 14. 1. Glaciers.
It is assumed that glaciers move slowly, but occasionally they have surges and move up to 50 times faster than normal.
2. Salinity.
The Dead Sea is famous for the salinity of its water.
3. Humidity.
The humidity in tropical areas can make you very tired.
4. Kilometers.
The oceans can reach depths of 11 kilometers in places.
5. Pressure.
Altitude sickness is due to a reduction in air pressure.
6. Evaporation.
Rain is mainly caused by evaporation from the oceans.
7. Environment.
We need to look after the environment around us.
8. Biology.
Biology is a branch of the natural sciences.
9. Brightness.
Our perception of the brightness of the sun changes with the seasons.
Track 15.
Hi everyone, how are you all?
I'm fine, thanks, Linda.
Actually, I'm not feeling so well. I think I've got a cold.
Oh no, Stephen, I'm sorry to hear that. What about you, Joanne?
I'm fine, but I'm very busy with my biology course.
Oh, me too. There's so much work to do.
In that case, we should get started on our essay. John, do you want to start?
Okay, let me start by telling you my ideas for the essay.
Track 16.
We've really got to decide who does what for our Natural Earth project.
Okay, Alice. Well, we've got all our cloud research, so let's decide how to break it down.
Well, we should probably start by saying how clouds are formed.
Good idea. And then maybe move on to the different types of clouds. We can separate it into low-lying, medium-level, and high clouds. What do you think, Jenny?
Yes, I think that's a good idea. And we should also make a PowerPoint to make it a bit more interesting and put in pictures of the different clouds.
Good idea, Jenny. We should probably have cue cards too. I'm useless at remembering what to say without them.
Yes, me too. Well, I'm quite happy to organize everything we found out about clouds and make sure it fits into our presentation times.
Actually, I'd better do that. I've got all the research on my computer, so it makes sense. How about if you make the presentation slides, Carl?
Okay, Alice, that's fine by me.
Well, if you guys are gonna do that, then I'll look on the internet for pictures of the different types of clouds.
That'll be great, Jenny. I'll also make the prompt cards so we don't forget what we're saying during the presentation.
Sounds great. Let's have a run-through on Tuesday. What sections does everyone want to talk about? I don't really mind.
I hate speaking in front of people, so I'd prefer not to do the introduction.
I don't mind, I'll do that. If you don't want to talk much, then why don't you just do the middle bit about the medium-level clouds?
Yes, I can do the low-level and high-level clouds part. I'm sure Jenny can handle the summarizing too.
Thanks, guys. We can all take questions together.
Track 17.
Hi, Roger.
Debbie, hi, how are you?
Oh, I've been struggling with my Natural Earth assignment. It's proving to be really difficult.
The one for Professor Black? Me too. I'm writing about volcanic activity. What are you doing yours on?
Acid rain. I thought that would be okay, but the process is really complicated.
Well, I can help you with it. I know a lot about acid rain. I studied the causes and effects last year.
Really? Oh, that's great. I've done some work on the causes. I'm going to write that acid rain is caused by sulfur dioxide from power plants and smelters. Basically, this reacts in the atmosphere to form acid rain.
Ah, but it's not just sulfur dioxide. It's also nitrogen oxides.
Really?
Yes, from things like car exhausts.
But aren't nitrogen oxides also caused by natural events too?
Yes, they're a minor factor, but I think they're worth mentioning. But sorry, carry on.
Thanks. I might add that. So anyway, these emissions react in the atmosphere with water, oxygen and oxidants to form acidic compounds like sulfuric acid. These compounds then fall to Earth.
Are you going to mention the different ways they return to the ground?
Do you mean wet and dry deposition?
Yes, so you've done a bit of background reading then.
Yes. So if I've got it right, acid rain often comes down as rain, but also as snow or fog. This is wet deposition. I'm also going to define it as any form of precipitation that removes acids from the atmosphere.
Yes, I think that's a good term to define it.
Dry deposition. Well, I think that's when the pollutants stick to the ground through dust. I'm not really sure how to define it though, compared to wet deposition.
Just think of it as any pollutants that are not caused through precipitation. That's probably the best way. Did you know that sunlight can enhance the effects of acid rain as well?
No, I didn't. Oh, there's so much to think about. I'm sure I'll go over my word limit.
Well, you sound like you know a lot about the subject. Just try and keep your focus. I've had the same problem writing about volcanoes. There's just so much.
Track 18.
Do you want to make a start on our Natural Earth project? I think our idea of a lightning safety presentation is great, don't you, Rachel?
Yes, I think it'll be really good. I have a few ideas already.
Oh, great. Me too. I think we should divide it into 2 parts. What to do if you're inside when lightning strikes and what to do if you're outside. What do you think?
That's good, but we need more. Something about planning for this kind of event. And also, what to do if someone gets hit by lightning.
Oh, I can't believe I forgot that. Of course. Well, what should we talk about in the first part?
I think we should say it's important to be aware. Lightning is always before rain, so don't wait until it rains. As soon as you hear thunder or lightning, you should get inside.
OK, yes. And then if you're indoors, you should avoid water, stay away from doors and windows, and don't use the telephone.
Or any electrical equipment. In fact, if you can, switch it off first. And you should wait half an hour after the last clap of thunder before going back outside.
And if you're outside when it storms, you also need to avoid water. Try and get inside as soon as possible. There are certain things you should avoid. Open spaces, anything large and made of metal. And of course, the obvious one, trees.
But we should mention that if lightning strikes very near you, you need to crouch down.
Oh, is that right? I thought you had to stand still.
No, that's actually wrong. You're supposed to crouch down.
And put your hands over your ears. The noise can damage your hearing if you don't. OK, I think we've got quite a lot here. Only the last part to go. Now, what to do if someone gets hit?
I think we should say that it's very rare for someone to get hit by lightning. Our talk sounds as if there's danger all around. We should try and make it sound a bit more reassuring.
Yes, you're right. We'll say it doesn't happen often. It's just better to be safe than sorry. But what should we say about getting hit by lightning?
Well, I think we should say it's safe to touch people who've been hit by lightning. They don't have any electrical charge. If there's a first aider around, then they should help them. Otherwise, it's just best to call for an ambulance. And we should remind our audience that 80% of lightning victims don't get fatally injured. That should calm everyone's nerves.
Track 19. Section 3. You will hear 3 students discussing a group project on weather conditions. First, you will have 20 seconds to look at questions 1 to 7. Now listen carefully and answer questions 1 to 7.
So, I think we'd better start planning what we're going to do for our group project. Have you guys had any ideas?
I was thinking we should do something on extreme weather events, but I think Alex had some different ideas.
Yes, maybe we should look into more localised weather conditions and the effects on the immediate environment.
That's a good idea, Alex, but I don't think we'd be able to get much data on that, and we don't really have time to do our own research. What about doing something about the seasons?
I think the seasons might be a bit too wide-reaching, you know, when we take into account the wind patterns and pressure systems.
Maybe you're right.
Well, how about Tom's idea of extreme weather conditions?
Yes, that sounds like a good idea. It's easy to break down into separate parts, and it certainly sounds more interesting.
I'd quite like to cover monsoons. I've been doing some reading on them and they're quite interesting.
Well, that sounds good. We should maybe take 2 areas each. That would make it easier for us to focus.
Well, we've got lots to choose from. We could do blizzards, heat waves, droughts, cyclones. There are loads. Why don't you do blizzards too, Tom?
I don't fancy doing them, but I wouldn't mind doing something on floods. They're linked to monsoons, I think, so it will be an easy transition. What do you fancy doing, Alex?
Well, I could always cover winds.
But that isn't really extreme enough.
I could do hurricanes. They're pretty exciting. How about doing cyclones, Emma?
I'd rather do heat waves and droughts, I think. I know a bit about them. I don't know anything about cyclones.
Cyclones are really interesting. I can cover them.
That sounds great. I was thinking about doing cyclones, but I'm happy for you to do them.
Before you hear the rest of the talk, you have 20 seconds to look at questions 8 to 10. Now listen and answer questions 8 to 10. Track 20.
Right, shall we get started on some of the content?
Yes, we haven't got that much time. Does anyone know anything about their topics?
I know quite a lot about cyclones.
Do you?
Well, I studied them at high school. You know, cyclones usually start near the equator. They need quite warm water to form. Above the warm water, the vapour in the air forms clouds, and if there is low pressure, then these clouds will start to rotate.
Isn't it also the fact that the Earth rotates too, which makes the clouds spin more?
Yes, that too. Once they begin rotating, they can either lose momentum or keep gathering momentum until they hit land. These ones are called mature cyclones. Luckily, as soon as they hit land, they start to lose momentum and fade away, just because they don't have the warmth of the ocean underneath.
Well, that's a relief.
They can still be really destructive. They are like a big circle of wind. They blow strongly until the eye of the storm passes, you know, the centre, where everything is really quiet, no wind or anything. But then the other side hits and the winds blow just as strongly, but in the other direction. It's just amazing. Yes, I would really like to cover that.
Well, it looks like we've got it all arranged then.
That is the end of section 3. In the exam, you will have half a minute to check your answers.